Hey guys, so let's look at 3.2, part 2. So we're still adding, subtracting, and multiplying polynomials. In fact, problem number 1 here, I've got 3 different polynomials to multiply. So I am going to do a lot of distributing. In fact, I'm just going to work with the first 2 polynomials. I'll leave that x plus 5 out for a sec. I'm just distributing the first 2. So x times x is an x squared. X times 4 is a 4x. Okay, so I distributed my x. The negative 1, let's distribute the negative 1. So I get a negative 1 times x and a negative 1 times 4. All right, so that's those first 2 distributed. I still haven't touched the x plus 5, the third one. I think I'm going to combine some like terms here. My 4x minus 1x, 4 minus 1 is 3, so I got a 3x here. And I still have the x squared there. I still have the negative 4. So that's all simplified as much as I can. And now I'm going to distribute it to my x plus 5. So let's do this again. I'm going to distribute the x squared to both of them in the other set of parentheses. So x squared times x is x to the third, and x squared times 5, so 5x squared. Next step, I'm going to distribute the 3x to, again, everything in the other set of parentheses. So 3x times x is 3x squared. 3x times 5 is a 15x. All right. And last but not least, let's distribute the negative 4 to, again, everything in the other set of parentheses. So negative 4 times x and negative 4 times positive 5, so a negative 20. All right, so let's combine some like terms here. I got a couple x squareds. I got a couple of plain x's. So let's combine these. The x cubed has nothing to combine it with. 5x squared and 3x squared. 5 plus 3 is 8, so I get an 8x squared. For my plain x's, I have a 15 minus 4, which is 11, a positive 11x. And then the negative 20 has nothing to combine with. So here is my final answer. Okay, so these are special product patterns, product meaning multiplication. So if I have the positive b and negative b, like a positive and negative of the same, either number or variable, either way, it will end up being a squared minus b squared. The a is your first, let's put this in green here, first term that I had in mine, it was both an x instead of an a, but that's fine. I've got the a squared, so my x squared, minus the b squared. I had a positive b and a negative b. In this case, I have a positive 3 and negative 3. So I get a 3 squared, which I can simplify down. 3 squared is 9. So I would end up it would end up as x squared minus 9. All right, so the square of a binomial, meaning something squared. You got this whole 2 terms, binomial squared. Let's again treat this like I'm substituting, instead of a's, I've got like a y. And then instead of my b's, I think I have a 4. So according to what this equals, it'll equal my a squared, again, like a y squared, plus 2 times a times b. So my y is the a and the b is a 4. So plus 2 times y times 4. And then plus your b squared, which the b again is a 4, so a 4 squared here. So there is a little simplifying to do. I got my y squared. I've got 2 times 4. If I'm simplifying this down, 2 times 4 is 8, so I get 8y. And 4 squared, 4 times 4 is 16. So I've got this like 8y plus 16. So that would be totally simplified. All right, but the same rule applies to the next one as well. It's just got subtraction going between it. You've got an a minus b, which according to this, the a is actually the entire thing at the beginning, the entire 2t, and the b is the entire thing that I'm subtracting. I was subtracting just the number 5 in this case, but whatever it is I'm subtracting. And then the tricky part is I need an a squared, and my a was actually 2t. If you just put 2t squared, that actually is incorrect. I needed package deal here. The entire 2t, the entire whatever the a is, got squared. Plus 2 times the a, so the 2t, times the b, which was a 5 in this case, and then plus the b squared, so plus my 5 squared. So this one did have a little more simplifying to do, and careful about the exponents here. I got the 2 squared and the t squared. 2 squared is 4, and there's my t squared. The middle part here, let's simplify this down. I've got a 2 times 2 times 5. So 2 times 2 is 4, times 5 is 20. So I've got a 20t. And this last number right here, that is a 5 squared, which 5 squared is 25, so plus 25. All right, so that is totally simplified down. And then you've got the cubes as well. So I think I'm gonna kind of move on. I think you guys probably know how to use the formula, how to plug and chug, but the last one I do want to specify, like I did with the 2t, I had to plug in the entire 2t. This one I got to plug in the entire m squared for my a. So like you need parentheses around the entire m squared. For the a that got cubed, I've got the entire m squared cubed. Minus 3 times a squared. Again, my entire a is the entire m squared. Okay. And the b in this case was, what I was subtracting was a 2. So then times 2. And then you've got plus 3 times a times b. And again, the a is the entire m squared. And then I've got a b squared on this one. So like a 2 squared. And then you've got minus b to the third at the end here. So this one's pretty lengthy. But my point is, don't forget the parentheses. Okay. So this is a binomial, is a polynomial with 2 terms. Bi, like 2. Tri, if you had like a trinomial, that would be 3 terms, and so on. Okay, so I know I could simplify that a little more, but I'm going to move on and pretty much do the same thing down here. So this one, I think it matches the sum and difference. Like I've got addition and subtraction of the same thing. So this sum and difference, I'm going to do a squared minus b squared. A being this first guy, an x, and the b is this second number, a 3. So according to my formula, I'm going to get a squared minus b squared. So x squared minus 3 squared, which I can simplify down a little bit. I know that 3 squared is 9, so x squared minus 9. All right. And the next one, number 3, I've got y plus 4 all squared. I'm thinking this matches the a plus b, like my y plus 4 all squared. In fact, I already did that one. So we already simplified it all down and everything into this guy, the y squared plus 8y plus 16. Okay. But yeah, you had to combine your, and not really combine like terms, you just have to kind of simplify it down. And let's see what else we got. 2t minus 5, I think we already did this one. Yeah, 2t minus 5 all got squared. So can you identify which formula we used? That one, we used, this guy was subtraction in there. And it was a 2t minus 5. 2t for the a, 5 for the b. So simplified down to this guy, 4t squared plus 20t plus 25. All right, z plus 3 cubed. Okay, this is the one we didn't do. Z plus 3 cubed. I think it's going to match my a plus b cubed. My a is the z, and the b is the 3. Okay, so again, I'm looking at that top one there. I've got an a plus b all cubed. So according to this formula, right here, I've got the a cubed. Again, we already said my a was a z, so like a z cubed. Plus, next up is the 3a squared b. 3a is a z again, so like z squared b, and my b was a 3. So this is my 3a squared b. All right, next up then I have another 3, 3ab squared. Okay, so the 3a, just plain a, which in this case the a is a z, and then b is the one that got squared, so my b3 got squared. All right, so we took care of that term. And last but not least is the plus b cubed, which my b is a 3, so like plus 3 cubed. All right, so I plugged all the numbers, or I plugged my a and my b in, but I do need to simplify some. So let's see if we can simplify down a little bit. I got z cubed. These guys, as far as constants go, I've got a 3 times 3 for 9. And as far as variables go, I've got z squared, so I got a 9z squared. The next term, I still have a plus sign here, but I have 3 times 3 squared. 3 squared is 9, so I have like a 3 times 9, so 27 in front of my plane z. And then again, 3 cubed, so 3 times 3 times 3 is another 27. Okay, and I can't really combine any like terms, so that's as good as it's going to get right there. All right, and the last but not least here, this was kind of what I was setting up here. I haven't simplified it yet though. It had the m squared all to the third, so I'll write that down here. All right, and then I had, let's see here, minus 3 m squared all squared, and then times the 2. Okay, and then next one was the, get rid of that. Okay, next one was a 3 times m squared. This was not raised to another exponent. It was just straight up m squared. 3m squared and then 2 squared. All right, and then the last piece that I have here is the minus 2 cubed. Okay. Which means, let's see if I can simplify. An exponent raised to another exponent. This rule I actually had at the top. We didn't talk about it yet. But whenever I have an exponent raised to another exponent, I do what this is saying. I multiply those two exponents. And then I don't need any more parentheses. So let's do that on this guy. I'm going to multiply my 2 times 3 for 6. And then I don't need any parentheses. It's just m to the 6th. Same thing, all this other m. Exponent raised to another exponent. I'm going to do a 2 times 2 for a 4. So I'm going to have like an m to the 4th. That also has some coefficients though. I took care of the variable and its exponent. I haven't really messed with the negative 3 times 2 though, the constants. So negative 3 times 2 is a negative 6. So this is, I'm going to move this over here a little bit, negative 6 times m to the 4th. All right, I don't have like an exponent to another exponent. It's just straight up m squared on that one. The coefficients though, I've got a 3 times 2 squared. 2 squared is 4, so I basically have a 3 times 4, so 12. I've got a 12m squared. And last but not least here, minus the 2 cubed. 2 cubed is 8, so minus 8. And none of these are like terms, so this is my final answer. All right, there we go, guys.